So we did use substitution yesterday. Oh. So one other type of problem that we didn't get to do yesterday is if you have a trig problem, a substitution that requires an identity. So remember last year in pre-calculus you learned the trig identities in chapter 5. In calculus they show up in a small amount. Okay, so here's an example of one that you're going to use an identity for. So here you have cosine cubed x, right? Cosine cubed x is hard to integrate. So what we can do is we can write this as, first of all, cosine of x cubed dx, right? Now, so this is cosine times cosine times cosine. A trick I could do is split this up into cosine of x times cosine squared x dx. Okay? Now, why do we do this and when do we do it? This is an option that you consider when you have sine or cosine to a power higher than 2. All right? And so you want to reduce that power somehow. So you want to split it up. Now, in trig, we learn trig identities, and we can deal with regular sines and cosines to the power of 1. And we can deal with sine squared, cosine squared, right, to the power of 2. That's why it's optimal to write it in terms of a single cosine and then a cosine squared. Now, the most common trig identity is the Pythagorean identity that says cosine squared x plus sine squared x is equal to 1. Okay? Now, what do I have here? I have cosine squared x. I'm going to substitute that with an identity. So if I take that identity in the blue and solve it for cosine squared, right, I subtract the sine squared, I get cosine squared is 1 minus sine squared x. So now what I'm going to do is I'm going to rewrite this as cosine x, and then this is going to be 1 minus sine squared x dx. I haven't done any calculus yet. Whatever I did, you could have done last year in pre-calc. Okay. Now, I have a cosine and I have a 1 minus sine squared x. All right? Where is the more complex version, the purple or the blue? Blue. The blue. In here, what do I take as my okay. So this is 1 minus sine of x squared. So you take sine of x. Okay? So this is the more complex, and then I take the one inside. So technically it's 1 minus something squared. I'm going to take the stuff inside the sine. So u is going to be sine x. Du is going to be cosine x dx. Not negative, positive. So now, look at this. When I integrate this, when I substitute it, okay, cosine x dx, these two is how much? Du. All right? And then what do I have in the blue part? 1 minus u squared. So here I have 1 minus u squared, and then the rest is just du. Okay? Now I can take the antiderivative. That's going to be u minus u cubed over 3 plus c. So now, because the antiderivative of 1 is u. And then so that's going to be sine of x minus sine cubed of x over 3 plus c. Okay? So now, the question you're going to ask me now is, okay, how do you know when to do all this? And the answer is, when you have sine or cosine to the power of 3, all right? Now you know, there are, tips and tricks, and now I've told you that when you have sine or cosine to the power of 3, this is what you do, all right? We're going to rely on our pre-calculus knowledge and then do it that way. The only other, confusing part, if I want to say, is how to pick the u, right? So this is what I had over there. I had cosine x, and then I have 1 minus sine of x squared, right? So you understand that the complex function is the stuff in the parentheses. And then if you go to the innermost function of this, it's what? Sine of x. Okay? So you have to go to the innermost. So that's how we do ones with substitutions. We're not going to do in this class the ones that are, that get totally crazy. This is probably like the extent of it. Okay? Okay. So here, what if you have a definite integral? So what if you have bounds a to b, -1 to 2, 0 to 5? How do you do it then? Okay, so the way we do it is, if you have f of u of x times u prime of x, okay, when we integrate, basically, we have f of u, so we write the function in terms of u, and then what we do is here, we have to change the boundaries. Change a to u of a and b to u of b. Okay? So you have to change those boundaries. All right, so here's how we do that. All right, let's integrate this like we were yesterday. All right, so we have x over x squared minus 4. What do you think the u is going to be in this case? X squared minus 4. Okay? So u is going to be x squared minus 4. So what's... No, just that one, and then we're going to do like over. Okay? Yeah. So du is 2x dx. Right, I'm not there yet. Okay, so du is 2x dx.
Why is it 2x dx?
Because the derivative of this, the 2 comes down. All right. So now, take a look at what we've got here. This, right, is 1 over u. Is that right? And then what do I have left? I have x dx. So now the leftover parts, right, you have to substitute from here. So if you have x dx left here, then here your du, you need to solve it for x dx. So that's going to be half du equal to x dx. Okay, so this is the u, and it's in the denominator. Right. Okay, so it's 1 over u, and then we have half du. So far, everything we did is from yesterday. Now what we're going to do is this. We're going to change this to u of 1. U of 1 is what? What was our u? X squared minus 4. So it's 1 squared minus 4, negative 3. And then I'm going to change this, and I'm going to do u of 0, 0 squared minus 4, negative 4. Why did I do this? I'll tell you. 0 and 1 are the boundaries when this is a function of x. When we change this to a function of u, it no longer has the same boundaries. It's a completely different function. So you have to change it and give it its own numbers. Now, can I take an integral of this?
Yeah.
It's going to be 1/2 of what?
ln of
No, 1 over.
ln, yeah. ln of u from -4 to -3. Notice, I keep the absolute value in there. Okay, now when I have a definite integral, I don't have to bother with putting the u back in here. I could just substitute the values here. So now I'm going to do 1/2 times, put in the -3, and I have ln of -3 in absolute values, minus, put in the -4, ln of -4. Okay, so how much is that? This is 1/2 ln of 3 minus ln of 4. Think back to algebra 2. This is 1/2 ln of 3 over 4. And there you have it. Huh? Okay. Yeah. Okay, so I'm wondering to do this now or later. Okay, so I'll do it now. Suppose you're just morally opposed to changing these numbers. Okay? So suppose you didn't want to change the numbers. So you get 1 over 2, 1 over u du. And you're like, you know what? I don't want to change the numbers. Not changing bounds. Because I don't know, you're just philosophically opposed to this. Okay? What you would do is this. This is equal to 1/2 ln of u. I'm sorry, hang on. Yeah. Give me a second though. Let me do this. 1/2 ln of u. That's it. Okay? And now, if you didn't change the bounds, then at this step, you're going to do 1/2 ln, and what was the u? X squared minus 4. You put that in here now. Okay? And you go from 0 to 1. Okay? This whole thing from 0 to 1. Yeah, it's an extra step. So now this is 1/2 ln of, you put the 1 in there, what do you get?
3.
Right, absolute value of -3 minus ln of -4, and boom, same answer. Huh? So you either leave the bounds the same, you plug in the u back and then use the same bounds, or you change the bounds and do it that way. Okay? All right. So, okay. This is an interesting one, because what would you say the u should be? Okay, so let's say u was secant x, right? Then what would be
No, it's 10x.
du?
There is
What would be what?
10x
du.
secant x. No,
Du would be
secant
10x
squared.
dx.
No, secant
10x.
squared x.
10x.
I mean, secant squared x is 10x. Right?
Okay, so let's take this as the u, right? Because what's the derivative of tangent? It's secant squared, right? So if u equals tangent x, du is secant squared x dx, and then it just works. So now, this is u, this is du. Okay? Now, I'm going to change the bounds. So I say, okay, u of pi over 3 is equal to tangent of pi over 3, and that's root 3. I'm going to ruin the surprise for you. Okay? U of 0 is tangent of 0, and how much is that? 0. Okay? Now I integrate, and that's no. So tangent is 0.
Oh, it's cosine of
Sine over cosine. Sine of 0 is 0. Cosine is 1.
Oh, seeing the other way around.
So that's u squared over 2. And we're going to go from 0 to root 3. So that's root 3 squared over 2 minus 0 over 2, which is 3 over 2. Okay. It won't be. Because then it's not integrable.